welcome to the 29th lecture on probability and statistics, and in this lecture we will study conditional probability. Before this we have studied joint probability, which is also called the intersection of the probability of intersection of two events A and B. This intersection, the probability of intersection, is also written as the joint probability, probability of A, then a comma, and then B, which can also be written as probability of A times probability of B given A, where B given A is the conditional probability term that we studied in last lecture. B given A means the probability of happening event B or occurring event B when A is definitely occurring. It can also be written as probability of B first and then probability of A given B, means the probability of occurring A when B is definitely occurring. So let's understand it better with the help of an example. Suppose we have a box here in which are 6 green and 2 red balls. 2 balls are picked at random. Probability that both are red, right? So since we have 6 green and 2 red balls, so let's call the two draws as D1 and D2. In the first draw we can get a red ball or a green ball. The probability of drawing a red ball is 2 out of 8. There are 8 balls in total, and the probability of drawing a green ball out is 6 over 8. Why 6? Because there are 6 balls, 6 green balls, and the probability of drawing a green ball is larger than drawing a red ball. So let's see what is the probability that they both are red, right? So actually we have to make 2 draws. In the first draw we will draw a ball that can be either a red or a green, and then we have to make another draw that can also be a red or a green, right? So and these 2 draws are, the second draw is without replacement. We draw a ball permanently. Suppose we draw a red ball, we draw it permanently, we don't put it back, right? So this is the probability that we have to compute, that out of draw 1 we get R and out of draw 2 we get R. So this can be written as a joint probability term. That draw 1 gives us a red ball and draw 2 also gives us a red ball. This joint probability term can also be written as using this formula that we studied in this lecture as well as in the last lecture, that the probability that draw 2 gives us a red ball given that draw 1 also gave us the red ball, multiplied by the draw 1 gave us a red ball. So this is A, B, this is B given A, this is A. So exactly like this. Like this. So based on our knowledge of how we can decompose a joint probability term into a conditional and a marginal probability term, we'll take this problem. Right, probability of draw 1 gives us a red ball is 2 out of 8 because we have 2 red and 6 green balls. 2 out of the total number of balls 8. It can also be simplified as 1 over 4. Right, once we have drawn it permanently. What is the probability of drawing a red ball in the second draw? Whereas in the first draw we definitely drew a red ball. This means we are left only with 1 red and 6 green balls. So the probability of drawing a red ball now is 1 over 7 because there are 7 balls in total and there's only 1 red out of these 7. So probability of D1 R and D2 also R red is this term, that is 1 over 7, and multiplied by this term, that is 1 over 4. So multiplying the two gives us 1 over 28. This is the probability of drawing a red ball as of in the first draw as well as in the second draw, joint probability term. So we have learned how to tackle this problem, the joint probability term, how to compute this term using the conditional and the marginal probability terms. Right, the second part of this question is that whether the draw 1 in which we get a red ball, drawing red ball as draw 1 and drawing red ball as a result of draw 2, are these events independent? Right, we studied earlier the two events are independent if the joint probability term is equal to the product of their marginal probability terms. For example, probability of A, B is probability of A times probability of B only if A and B are independent events. So whether this event and this event are they independent? Let's check using the knowledge we have. So we have to actually verify this expression. If we prove that left hand side is equal to the right hand side, these two events will be independent. But if we don't, they are not independent. So the left hand side is given. We have just calculated the left hand side in our last slide. D1R, D2R is 1 over 28. So this is what we already know. So what we have to compute is D1, probability of draw 1 gives us R and draw 2 gives us R. Probability of draw 1 gives us R is simple because we are given this box and drawing a red ball is 2 over 8. The probability is 2 over 8 or 1 over 4. But D2 probability of D2 gives us R is a bit complicated because D2R and there are two options for R for D1. D1 can be R, D1 can be a G, it can be a red, it can be a green. So the probability, the sum rules tells us that probability of D2 is R is the draw 2 gives us R and draw 1 gives us red. Draw 2 gives us R while draw 1 gives us green. We can decompose these two joint probability terms into marginal times the conditional probability terms. And then we can calculate them individually. For example, what is the probability that D2 gives us R given D1 gave us R? So once R has been removed, there is only one red. So red is 1 over 7. What is this term? D2 is R. D2R given D1 was a green. So this means that draw 1 was definitely a green. So we are left with 5 green balls instead of 6, but there are 2 red balls. So drawing a red ball now is 2. The probability of drawing a red ball now is 2 over 7 because we have 7 balls in total. Out of those, 2 are red. D1 is green is simple, 6 over 8 because 6 balls, we have 6 balls initially, 6 green balls and 2 red balls, so 6 over 8 or 3 over 4. So probability of D2 is equal to R. Now we have computed everything. To compute probability of D2 is equal to R, putting everything in gives us 7 over 28. So probability of D1 is equal to red times D2 is equal to red is 7 over 112, which is equal to the right hand side. So what was the left hand side? Left hand side is 7 over 112. What was the left hand side? It was 1 over 28. So they are different. They are not the same. 1 over 28, 7 over 112. Right. So they are not equal. This means the left hand side is not equal to the right hand side. This means that D1 is equal to red and D2 is equal to red. They are not independent events. They are dependent on each other, and they have to be because draw 2 is dependent on what we have drawn in draw 1. So that's an illustration of conditional probability, or the use of conditional probability in conjunction with the joint probability and marginal probabilities, giving us some good information or a basic understanding of conditional, joint and marginal probability terms. Right, we will keep on studying more about this in our next lecture. Thank you.